really excited to be starting off your webinar series today, just discussing primarily genetics and how we successfully select sires for beef on dairy crossbreeding. So to start, we know that beef on dairy adds value to the dairy herd. Here in Pennsylvania right now, we're seeing day-old beef on dairy calves sell at the sale barn for over $900 a head. So we know for the dairy farmers, at least right now, while the cow herd is small, are making quite a bit of profit on beef on dairy. And even when we see cow herd regrowth, we'll probably see that beef on dairy continue to occur simply because these beef on dairy calves are always going to be valued a little bit more than the Holstein bull calf, and because dairy farmers, with improvement due to genetics and management, they've improved reproduction, production, and health in their herd, which means they need fewer matings to generate replacements. Plus, we have sex semen, and sex semen fertility has improved quite a bit in recent years, which makes it very plausible for dairy farmers to set up these breeding schemes where they can generate all of the replacement heifers they need selectively from their genetically superior animals, which leaves a whole lot of cows that still need to have lactations that they can then mate to beef semen and add that nice value, which again, right now looks really good with that $900 per calf. So when I was given the topic of conception to consumption for this webinar, I was actually really excited because that is a phrase I have used in the past for some of these extension discussions, because really when you're talking about genetics and sire selection, you have to think about beef on dairy production beginning at conception on the dairy all the way through consumption of the final beef product, which there have been some gaps in, especially when this began back in 2017 on a wide basis. So on the dairy producer side, with conception and birth, their main focus is how those things are impacting the dairy dam. They are less concerned about the final beef product unless they are raising beef for a freezer beef program, etc. Sorry about that. So really, when dairy farmers are considering selecting sires, they're often thinking primarily within that conception and birth phase of things. However, we know that weaning through consumption are all very important in beef production, and it really is what needs to be considered at the time of mating to maintain that value of beef on dairy, and so those calves continue to hold value over the Holstein bull calf. So that brings us to the question, what beef sire breed should we use? And which beef sire should we use within that breed? But before we can even ask those questions, I do want to answer a couple of questions related to the dairy farmer, just very briefly. So dairy producers need to know what cows they should even be breeding to beef and how many cows. Just for if there are any dairy farmers on here, this is one tool that I would recommend using. Oftentimes stud companies produce very similar tools as well, where essentially you can input your pregnancy rates, your conception rates, the number of cows you're mating, and the number of replacements you need to get different economic values related to beef on dairy breeding. So that can help you figure out and select what animals to breed to beef versus what animals you might want to breed to sexed or conventional semen. Another thing that needs to be considered on the dairy farm is how we're breeding this cow. Some dairies have chosen to use natural service, use a cleanup bull, maybe in addition to artificial insemination. And today, as I'm talking about breeding values and genetic selection, the one thing in relation to natural service and selecting a live bull for this is that I recommend you buy a tested bull from a bull test, because all of the same things apply as I discuss breeding values and fertility if you buy a bull through a bull test, because his fertility will be verified and he will have breeding values available. So throughout the rest of my discussion, I will primarily be referring to AI if I'm discussing how we're actually breeding her, but know that natural service all will apply in the same way, selecting a bull if you choose a bull from a bull test. So for a little bit of background on how we generate breeding values in cattle, it's pretty different between our dairy and beef industries, even though we use the same methods. In dairy cattle in the United States, there are 7 major registered breeds. And beyond that, we don't do, or our main organization doesn't perform evaluations really outside of those breed houses. So there is one central organization called the Council on Dairy Cattle Breeding that performs all of the genetic evaluations for these animals, which means that the breeding values that you get on dairy bulls are all very similar and all very comparable across breeds. Now, in beef production, on the other hand, there are many, many breed registries, and I did not put a number down because, gosh forbid, I counted wrong and I forgot some breed association. There are just so many out there. And because of that, or not necessarily because of that, but we don't have one central organization in the United States that's performing genetic evaluations. We have some different independent breed associations and some other associations that might perform genetic evaluations for multiple beef breeds, but some of the breeding values that are generated are not necessarily comparable between breeds, or you might see an EPD for one breed that doesn't exist for another breed. So the other thing is that there's a language difference. So if you're from the dairy side of things, you're used to looking at PTAs, or predicted transmitting ability. If you're from the beef side of things, you're used to looking at EPDs, or expected progeny differences. So those 3 words essentially mean the same things. If you're talking to a geneticist, they might debate with you a little bit that one language is a little bit more correct than the other, but for the sake of this presentation, they are essentially the same. And because we're talking about beef sire selection, I'll be discussing things in the terms of expected progeny differences. So for an understanding of what an EPD is, we have to think about what goes into calculating an EPD for a given trait. So back before genomics existed, EPDs were calculated using information from an animal's pedigree. So understanding the performance of all of the animals that they were related to, the performance of the animal themselves, as well as the performance of that animal's progeny. Now we primarily have GE EPDs, or genomically enhanced expected progeny differences, which are generated very similarly, but now we have the advantage of a genotype or genetic information included in there as well. So when we look at an EPD, like on the left side of my screen, you can see these are example EPDs for calving ease and birth weight. That EPD value itself is exactly what it's called, right? It's the expected amount a sire's progeny will differ from their breed-based population for a given trait. So for this bull, we expect that he will produce, or he will have calving ease that's about 17% better than average. And his calves' birth weight will be about 2.3 pounds less than average within his population. Now, the accuracy for both of these traits is 41%. So out of 1, as that accuracy value approaches 1, it means it's getting more accurate. And because these are GE EPDs, or genomically enhanced, that improves the accuracy, even if this bull doesn't necessarily have a lot of progeny. Finally, percentile rank is something that I often focus on when I'm selecting bulls because, again, things differ between breeds, but at least within breed, we can look at percentile rank and see where that sire ranks within his entire breed for a given trait. So this sire is in the top 7% of his breed for calving ease and the top 20% of his breed for birth weight. Now, presented here is a non-comprehensive list of EPD traits that are developed by various beef breed associations. And I've kind of split them out between production, maternal, management, and carcass traits. Now, with beef on dairy production, the main focus of this is terminal production. While I have had some questions recently about perhaps retaining some of those beef on dairy heifers to rebuild our cow herd, I don't necessarily think that will become commonplace, nor do I necessarily recommend it. So when I talk to dairy producers about what EPDs they should be focusing on when selecting bulls, I say, don't even look at the maternal or management ones. We really want to focus on what's going to add terminal value to that calf. And production-wise, again, for the dairy producer, calving ease and birth weight are important, but we need to focus on those growth and carcass traits as well for these calves. Now, as I mentioned, these EPD values are generated within breed. So there is also a tool to compare across breeds. If, for example, you were looking at an Angus bull and a Charolais bull that you were both interested, you were interested in using one or the other within your herd. So marked EPD adjustment factors are released every year by the Meat Animal Research Center in Nebraska. So they are based on their population of cattle. So they translate somewhat to the United States population of cattle because they're using a similar genetic base. So these help you translate EPDs across breeds, but they're only available for certain EPD traits and 14 breeds. So comparing this example, Angus and Charolais bull, so I have our Angus bull named Fireproof and our Charolais bull named New Man. Now, if I want to evaluate them both on their ability to produce progeny with high marbling scores and large ribeye areas, I have to perform the adjustment to compare them between breeds. I can see that within breed, both Fireproof is in the top 1% of all Angus bulls for marbling, as is New Man. But those EPD values are very different because they're two very different breeds. And now when I apply my EPD adjustment factor, which is minus 0.33 to the Charolais, I can see that Fireproof is predicted to add a lot more marbling to his progeny than New Man the Charolais. Likewise, when we compare our ribeye area EPDs, we can see that Fireproof is within the top 10% of the Angus breed for ribeye area, while New Man is only in the top 20% of the Charolais breed for ribeye area. However, when I apply that adjustment factor, which is plus 0.76, we can see that he's actually predicted to transmit more, or his progeny are expected to have greater ribeye areas than Fireproof's progeny. Now, selecting on individual EPDs is great, but economic selection indexes are tools that have been developed for producers to be able to incorporate many different EPDs into making their decisions. So they're applying economic values and weights to these different EPD traits to predict a dollar value of what these cattle will bring in. Angus, the Angus Association, has many, many economic selection indices, probably more than any other breed. And again, cross out maternal here because we don't really care about that for beef on dairy. But Angus Association has developed their own Angus on Holstein and Angus on Jersey indexes, as well as a number of other indexes that will determine value at weeding, value on feedlot, value as beef, etc. Now, again, if we use New Man, a Charolais, as an example to compare with Angus, some breed associations only develop one index for the breed. And with Charolais being a terminal breed, there is one index, and that's the terminal sire index. So that really just weights traits related to terminal growth and production of these cattle. So there are some breeds where there's a lot of choices that can be made using indices, and there are some where there's one index that kind of tells you how you can make your breeding decision. Now, if we actually think about how beef on dairy sire selection has occurred over time, again, I mentioned 2017 was kind of where we saw the really large takeoff in beef on dairy mating in the United States. And there were very few things that dairy producers or stud companies really cared about. It was a way for stud companies to kind of unload some semen that they couldn't necessarily sell to native beef producers. So the semen had to be cheap for the dairy producer to want to buy it. Dairy producers preferred black calves because they were getting greater value for those black calves, essentially because of the implication that eventually, as carcasses, they might be able to qualify for branded programs like certified Angus beef. They wanted the calves to be polled for ease of management. And of course, they wanted calving ease because they wanted to make sure that these calves were not impacting their dairy cows in any sort of negative way. Well, now we're in 2024, and every single stud company and a number of different breed associations, both dairy and beef breed associations, have developed their own programs and their own selection indices to try to market beef on dairy bulls to dairy producers. Now, they use a number of those traits that I was discussing, incorporating them into beef on dairy production. However, they're not always public. So it's a good idea to talk with your semen sales rep if you're interested in using one of these programs to figure out what these associations are weighing in their indexes, what they think is important for beef on dairy production. So now I want to talk a little bit more, and I kind of am going to go through this whole cycle of consumption through consumption on sire selection in beef on dairy to really try to answer those questions. What beef sire breed should we use? And maybe even which beef sire should we use within or between breeds? So to start with fertility for the dairy producer, that's really important for conception, right? In beef genetic evaluations, typically the only EPD you're going to see related to fertility is scrotal circumference. Now, scrotal circumference is good. It's correlated with bull fertility. It's also correlated with fertility for a bull's daughters. However, it doesn't necessarily directly tell you how fertile that semen from that bull is. Now, we do, and in dairy production, for semen, we have a value called sire conception rate. It's not a genetic value, but it does tell you based on dairy records how efficiently semen from that sire is allowing cows to conceive. So one thing that some bull studs are doing is that they're deriving their own male fertility evaluations, evaluating essentially sire conception rate for these beef sires by using data from dairy herds. So if you're a dairy producer looking to get more verified fertility and you can't using a breeding value, you can look for some of these branded programs from different bull studs. And a misconception that I always heard growing up on a dairy is that beef semen would improve conception when mated to dairy cows. If you had a difficult breeder, maybe you breed her to beef semen and she'll finally get pregnant. However, there is some data to show that sire conception was actually lower in beef on Holstein matings versus Holsteins that were mated to Holstein cows. Now, part of this they think was due to bias because of that idea that if you finally throw beef semen at her, maybe she'll get pregnant. So those hard breeders were getting bred to beef semen more frequently than cows that were conceiving right away. And if you think about it, it really makes sense, right? If we only bred our problem breeders to beef, they wouldn't suddenly conceive on the first service just because we're using beef semen. So now that she's pregnant, the dairy has a lot of other concerns related to birth, right? We know that individual calf sire can impact the rate of dystocia in a dairy cow. impact her gestation length, as well as impact her rate of stillbirth. Additionally, if a cow experiences one of these events around calving, she's likely to experience others as well because they're all correlated. So for example, if gestation length is longer or shorter than average in a dairy cow, she's more likely to experience dystocia or stillbirth events. And when she experiences those events, it results in health events, which result in economic losses, including milk production losses, both from milk that has to be dumped from having a treated cow, as well as a cow that's sick is not able to meet her genetic potential for milk production. So to kind of investigate how beef sire might be impacting this in the dairy herd, I used approximately 17,000 lactation records from beef on dairy matings from herds across the United States to investigate it and kind of compare how these beef on dairy matings were shaking out compared to to purebred Holstein matings. So starting with gestation length, I saw that gestation length was increased in every single cow that was mated to beef semen. When we split it down by breed, we saw that perhaps Angus wasn't really increasing gestation length by very long, a difference between 277 and 278 days, probably not going to result in increased dystocia, nor is it necessarily going to impact how a dairy farmer manages their herd. However, when we look at the increased gestation length in Holsteins that were mated to Limousin or Wagyu semen, we all of a sudden see a much greater difference of between 5 to 7 days, which economically and management-wise may have an impact. Now, with Limousin, the Limousin Association is actually one of the only beef breed associations that provides an EPD for gestation length. So dairy producers can actually, if they want to be using Limousin, but are worried about extended gestation length, can select on gestation length when they're selecting for Limousin bulls, but the same is not true with Wagyu in the United States. Now, in relation to calving ease and stillbirth, there were actually no differences between dystocia rates in beef versus Holstein sired calves. So that was great. Even though we saw some gestation length differences, it was not impacting dystocia. We did see some differences in stillbirth rate. However, I'd take that with a grain of caution. So this crossbred beef, we saw a higher probability of calves being stillborn if they were sired by these crossbred beef bulls. However, most of that data came from a single herd and is limited to some bulls that are marketed by a specific stud. So I think we would need more data to validate that that increased stillbirth rate is actually occurring. And when we compare Holstein to many of the other breeds that we saw being used, we saw no differences in stillbirth probability. So again, really good. And finally, looking at the performance of that cow in the lactation after she gave birth to either a Holstein or a beef sired calf, the calf sire breed did not impact the frequency of any health events that that cow might have experienced in early lactation, no matter how I broke those health events down by experiencing any or experiencing events very specific to something like mastitis. And likewise, there were no differences in milk or component production. So for the dairy side, we really are seeing that beef on dairy is profitable. There's no hidden costs related to cow performance or health. So on that side, there's not a ton of focus that needs to happen in sire selection to really be emphasizing calving ease. Gestation length might be something that dairies might want to focus on, but they really can only select that within the Limousin breed. Now, moving from our conception and birth of these calves into some of the growth and production. Now, related to weaning, we can select for weaning weights of beef on dairy calves. because weaning weight is a common EPD that's generated for beef cattle across breeds. However, weaning weight might not be the most telling within beef on dairy production because of the environmental differences between how we raise beef on dairy calves versus how we raise native beef calves. With these beef on dairy calves that are raised in hutches and weaned between 6 and 8 weeks of age, their age at weaning is quite different than how we evaluate it at 205 days in native beef production. And additionally, some research from Texas Tech has shown and kind of emphasized some of these differences due to environment. These researchers compared embryo transfer calves that were born to dairy dams and raised like beef on dairy calves or dairy calves, even though they were purebred beef calves, and they weighed less than native beef Angus calves that were raised on their dams at 150 days of age. So that makes sense because those Angus calves that were raised on their dams still had access to the milk bar. They were growing a little bit more and a little bit more efficiently while they were still on mom versus those hutch calves. So it's really hard to determine if selecting for weaning weight for beef on dairy production is really going to have the outcome that we see in native beef production. However, when we think about some of the other growth traits that we could use, yearling weight is one that could be a really good proxy when we select on growth. Some breeds also do have some more economically relevant traits related to growth for EPDs, specifically average daily gain and dry matter intake. So the data that I'm going to present related to growth following this, just so you know, this is all from my PhD research. And these are beef on dairy calves that we generated. We selected those sires based on their EPDs for growth and carcass traits. So focusing on yearling weight, average daily gain when we could for some breeds, and then on those carcass characteristics as well. So all of these sires across breeds, we really emphasized how their breeding values for growth and carcass production. So to begin, does sire breed impact growth? Now at feedlot arrival and at feedlot departure, sire breed did not impact growth in the beef on dairy steers that we grew out. Now, just to orient you quickly, we tested 7 different sire breeds, and across the top on these graphs, it is Angus, Red Angus, Charolais, Hereford, Wagyu, Limousin, and Simmental or Simangus. So no differences in body weight at feedlot arrival. Makes sense, they were all a similar age at that time, nor in final body weight, which again makes sense because we picked groups for slaughter based on body weight. However, where we did see breed differences was in that rate of gain. So average daily gain differed by sire breed, where we saw that those Angus, Charolais, and Simmental or Simangus sired calves all grew a little bit more efficiently, and they also ate more feed every day. So there actually were not differences by sire breed in feed to gain. Because they grew more efficiently, those breeds also spent fewer days on feed, especially when we compare them to our Wagyu sired calves and our Limousin sired calves. And just for relation, when we think about those Limousin sires that we selected, now at the time of selection, when we picked those Limousin bulls, the 2 bulls ranked within the top 3 and 30% of their breed. However, when we went back and to analyze the data, we saw that their ranking had actually changed quite a lot within breed, and that's because additional bulls were added to their breed and the accuracies of their EPDs had changed with more phenotypes from their progeny. So these Limousines were actually not very good yearling weight bulls. They were when we selected them in relationship to their relationship to the population at the time, but by the time we had killed their progeny, they were not. So that may be why we saw some reduced growth in those limousine calves. Now, as I move into our slaughter and consumption traits of these cattle, so carcass and quality, I do want to remind everyone how we price terminal cattle in the United States. Primarily, these cattle are being priced on a grid system for their carcass, where a base price is set based on carcass weight. And that base price is based on the assumption of a carcass achieving a USDA yield grade of 3 and a quality grade of choice. Now, as yield grade gets lower, which implies more muscle to trimmable fat, we see more premiums added to the carcass, as well as quality improves, we see more premiums added to the carcass. Likewise, if our yield grade gets higher or our quality grade gets lower, we see deductions taken from the carcass. Now, the carcass EPDs that we really focused on when selecting these sires for beef on dairy production were ribeye area, because ribeye area is typically discounted in Holsteins. Additionally, marbling was a focus. It is important to mention that Simmental and Sim Angus is the only breed association that predicts EPDs for tenderness, and we didn't necessarily select those sires based on their tenderness EPDs because we couldn't select sires of other breeds for the same thing. So in relation to our yield traits, sire breed really did not impact carcasses. We saw similar carcass weights among sire breeds, similar dressing percentages, which were ranged between 60 and 62%, so only a percentage point or two down from native beef cattle. Similar ribeye areas across sire breed and similar back fat. However, sire breed did impact our carcass quality. While pretty much among all of the cattle, they averaged a marbling score that equated to choice. We saw our Red Angus sire calves did achieve a marbling score of a average choice versus a low choice for the rest of those calves. And interestingly, when we look at those two Red Angus bulls, they fell high within their EPDs or within the Red Angus population for marbling, but they weren't necessarily the best. So we can kind of think about Red Angus contributing quite a bit of marbling to our beef on dairy progeny, at least those that rank within that top 30% of their breed. We also saw that within marbling and tenderness, Angus performed well. Angus had some of the most tender steaks. And even our Charlet, however, performed really similarly as we talk about quality, which might be a little bit surprising, especially when we think about our mark EPD adjustment factors. Charlet, even those that are best for marbling, really don't compare to Angus. So there's something beyond the genetics too, right, that's happening, or something on the dairy side of the genetics that's causing these calves to perform well. Now, the limousine had the lowest marbling scores out of all of the calves that we discussed, but they still equated to low choice. And again, if we look at the two limousine sires we used, one of them was within the top 5% of the breed. However, the other was in the top 65% of the breed. So that may be why we saw a little bit of a lower marbling score from those limousine progeny. Finally, we saw that our Simmental sired calves had the least tender carcasses, which again is interesting because our Simmental breed is the only breed that does genetic evaluations on tenderness. However, our Simmental sired calves were the only ones that didn't have a shear force value that equated to USDA certified tender. This is also interesting because I went back and I looked at the EPDs of the Simmental bulls that we used, and all of the Simmental bulls, with the exception of one, were in the top 20% of their breed for tenderness EPDs. And when I removed the progeny of that one bull that did not have great tenderness EPDs, the data didn't really change. So the Simmental breed is promoting selecting for tenderness, perhaps because they know that the carcasses of Simmentals or Simmental crosses aren't necessarily as tender as those of other breeds. Finally, I'd like to present to you the gross carcass values of these cattle that we fed out over 3 years. Now, I also ran the analysis after I put together this figure on our net values based on buy-in cost of those steers and feed costs for the cattle while they were on feed. And our values didn't change too much. So when we think about gross carcass value, it's somewhat equated to how our net values paid out as well. Now in 2021, we didn't have a lot of steers on feed, and we only had Angus and Simmental calves, so there was no difference in carcass value, and there was quite a bit of variation. In 2022, we had more animals on feed, and we saw that the Angus and Charolais sired beef on dairy carcasses were valued more than the Simmental and Wagyu sired carcasses. Now, this is probably for a couple of reasons. That year, those carcasses from Simmental sired calves did not grade as well as they did in other years. And also those Wagyu calves, even though it wasn't statistically significant, they finished a little bit lighter. So they were making less money for the carcass because we had fewer pounds that we were being paid for. Now, last year, where we fed out the most different breeds of cattle, we saw that Red Angus, Simmental, and Angus were all valued very similarly. Charolais was a little bit of an intermediate that year, so they did not perform as well compared to Angus as they did in 2022. And then we saw less value for our Hereford sired carcasses and our Limousin sired carcasses. Now, the Limousin sired carcasses, that makes sense, right? We saw a little bit less growth in those calves, and we saw a little bit less marbling on average. The Hereford sired calves might be a little bit of a surprise because they didn't really separate out in any of that other data I presented. However, again, when you apply economics, there actually was on average a greater proportion of yield grade 4s and 5s coming from those Herefords. So I think those yield grade discounts were really what impacted the carcass value this last year on those Hereford sired calves. Now, with all of this data that I have presented to you, it's really important to remember that phenotype, so the performance of these beef on dairy cows, is made up of genotype, or the genetics of these calves, as well as environment. And I really want to emphasize that because these calves, we fed and managed them a lot like you would manage and feed fed Holstein steers for ideal production. So they were implanted, they were fed high energy rations, and we managed them according to conventional beef production to try to get the best performance and express differences in their genetics. They all performed relatively well, but it wasn't just because we selected them, but we also managed them for production. And I think throughout the rest of this seminar series, the other speakers will speak a lot more to the management side of things, and that is just as important as starting with foundationally good genetics. However, that doesn't underemphasize the genetics either, because it's a lot harder to feed a really crappy genetic steer than a really good one, right? And with these calves already being half dairy or half Holstein, those sire genetics are so important to try to make up for some of those differences in these beef on dairy calves. So really, when we think about selecting a sire for beef on dairy, what we want to focus on is those terminal EPDs, those EPDs that are related to growth and production. We know that calving ease is not really impacted compared to Holstein calving ease in beef on dairy matings. Oh, I apologize. My cat just stepped on my keyboard. So we know that calving ease isn't really different, so that's not necessarily an EPD we need to focus on as much. We want to focus on those growth and production calving or those growth and production EPD traits, because that's where we're seeing economic differences for the feed yard and for the meat packer. When selecting beef bulls, I think one of the easiest ways to do it is looking at percentile rank within a breed, because the better a sire's offspring will be within that trait for their breeds. I think any breed can be used if you are, again, selecting for those sires that are genetically superior within their breed. There are lots of different options being marketed by studs and breed associations, so it's important to know what your market is. Sometimes some of these markets will actually produce, some of these markets have contracts, so perhaps using certain genetics from a certain stud is going to get you a more fair price for your calves. It's important for dairies to know that gestation length is increased by certain beef sire breeds and beef on dairy matings. Additionally, our data suggests that some sire breeds are going to result in more efficient growth, although not necessarily more feed efficiency. So we saw those Angus, Charolais, and Simmental sire calves required fewer days on feed, but they weren't necessarily more feed efficient. Finally, I think it's really important to note that we really saw that these beef on Holstein steers, regardless of sire breed, created really high quality beef. Again, with that caveat that these calves were from quality genetics and from quality management. So thinking about those two important things that result in superior beef production. With that, I would like to acknowledge that these data were supported, or the generation of these data were supported by 2 different USDA grants. I'd also like to acknowledge the support of our collaborators, the Pennsylvania Department of Agriculture, Livestock Evaluation Center, Premier Select Sires, and JBS USA. With that, I'd like to thank you all for your attention and open up the floor to any questions. I see that some have already been popping up in the chat. So I can
Bailey, we do have a few questions. Instead of making you dig for them and look for them, I'll go ahead and read them off to you. So one of our attendees early on asked $900 for a day-old dairy by beef crossbred calf. How does that compare to a purebred dairy calf?
So right now, at least in our region, we're still getting between $500 and $600 for those Holstein calves, Holstein bull calves. And that's really just because of the cattle market we're in right now, right? The feed yards are looking for cattle to fill. We don't have enough cows making native beef calves. So people are paying an arm and a leg for both dairy breed calves and beef on dairy, but the premium on the beef on dairy is obvious.
Another question from Levi Geyer. How much does the conception rate differ from sex semen versus non-sex semen? And are we seeing more beef type sex semen on the male side being used in these dairy production systems?
So conception rate differences do exist. I don't want to say a number off the top of my head because I am not a reproductive physiologist, nor am I working with those records every day. But I do know that there is slightly lower conception with the sexed semen. However, that's why it's one of the reasons that it's being recommended that you breed your heifers to sex semen on the dairy side. So heifers are often the most genetically superior animals in the dairy herd, as well as being the most fertile. So some of those differences in conception rate with sex semen are being made up for by doing selective breeding. But to answer your second question, we have certainly seen some more sexed semen being used for these beef on dairy matings as well. And again, that is that male sexed semen. So trying to get value added by producing a male calf I think primarily where that's happening is on dairies that have contracts with stud companies, because then they can get that male sex semen a little bit more affordably. What I will say as well in relation to those $900 beef on dairy calves we're seeing right now, originally, again, starting 2018, 2019, when these calves started hitting the ground, those heifers were definitely discounted, the beef on dairy heifers, in comparison to the beef on dairy bull calves. Right now, where we're trying to fill the feedlots with anything we can, we're seeing beef on dairy heifer calves pull very similar value per head to the bull calves.
Thank you, Bailey. Another question that may or may not fall in your purview is, what about the utility of blended or multi-sire straws?
So with relation to genetic selection or relation to fertility?
Well, I would say let's answer both.
Perfect. All right. So there's definitely data that supports using those blended straws specifically because of improved fertility. So that is verifiably there. I don't know as much related to genetic selection because those are being marketed by studs. One of them I know, it's from a private index. So if you as the cattle buyer or as the dairy producer and you're really interested and you want to know what genetics are going into it, sometimes you don't know. So the stud will say, oh, they're comparable on an index, which is probably true. I think they're probably marketing everything quite right. But if you're more interested and want to focus on marbling or ribeye, especially perhaps if you're marketing this beef yourself, I think that sometimes that can be a little bit more challenging when you want to know what sire you're using.
Another follow-up question. As far as the carcass value, the slide you presented, what was the numbers of individuals for each breed similar to those that you showed with the growth numbers, or what numbers for each sire breed were there?
Yep. So that was identical. Those are all the same animals. What you saw based on those slides, I can go back here. We had, because we made these from planned matings, we were not using sex semen, and we had different dairies that we were using to produce these calves that had different preferences for what sire breeds they wanted to use. And additionally, you can see we had a very low number of Wagyu sired calves in this study, basically because we generated them for 1 year and didn't really want to use Wagyu again after that. We weren't very excited about it, and they had some health issues, so some of them died before we could feed them out. So this is all definitely preliminary data. And if folks wanted to compare sire breeds more definitively, we'd need a bigger sample size for some of these breeds.
So what differences do you anticipate in carcass quality grade or marbling score when using just a general unknown Angus genetics versus Angus genetics that have been genetically selected for propensity to grade choice or marbling?
So I think that's a difficult question to answer. Angus are a breed that are known for marbling, and you could see that across these calves, even where we saw like that limousine bull that re-ranked to be pretty poor for marbling within his breed, those calves were still grading an average of choice. And Holstein sired beef, or I guess Holstein steers in general, typically perform pretty well for marbling. Likely less so because of genetics and more so because we're putting these calves on grain at a very young age. So I think we would still see sufficient marbling. However, by selecting those Angus sires or sires from any breed that have that higher propensity for marbling are going to be how you're getting more of those primes. And with the prime choice split we're seeing right now, that's what I would be interested in.
Another question, if the beef cattle herd begins to rebuild like we expect it to, if we get rain and everything else that goes with that, how is it expected to impact the value of these crossbred calves?
Yeah, so I don't think these crossbred calves are going to be selling for $900 forever. So I think it's going to look a lot more like when these calves were first hitting the ground back in 2018, 2019, where essentially I think if we fully rebuild that calf herd, those Holstein bull calves are going to be losing their value again for potential on feed. So essentially $0 a head for those Holstein bull calves, or what we were seeing when I was finishing up my undergrad was we were getting bills for the Holstein bull calves because sending them to the sale barn cost more than what we were getting for them. While those beef on dairy calves are still going to pull at least $100 a head. So you're not going to be losing money on them, and you're still going to be producing a calf and getting a cow going into lactation. And I think with all of the research that I presented and the research that will be presented within the next few weeks in this webinar series, we're finally more than 5 years in figuring out how to feed, how to manage, how to breed these beef on dairy buggers, and that will really help maintain their value when we rebuild the cow herd.
And one final question that I'm seeing, do we have any data to share about carcass adjusted cost of production differences across those sire breeds?
Carcass adjusted cost of production. So if I'm understanding this question right, we have an extension article that will be published on the Penn State Extension website within the next month or so, I believe, and it will also be published in Horde's Dairyman at some point, where I actually did go through and calculate input costs on those calves. And so then adjusting for net value, we saw very similar breakdown by sire breeds, where we saw a little bit less value for those Limousine and Hereford sired calves and a little bit more consistent value for those Angus, Simmental, and Charolais. So basically, because even though they weren't necessarily more feed efficient, they spent a few days less on feed, so a little bit less yardage expenses, as well as having slightly heavier carcasses.
Excellent. Yeah, whenever you get that article published, if you would send it, we can share it on our website as well, and that would be excellent.
Absolutely, be happy to do that.
Another question, any thoughts or data from this group on liver abscesses coming from these beef on dairy? We do have an entire session on this later on, but this has been really kind of come forward here recently. So
yeah, that's a huge question, and I personally don't have the data for it. It is coming from Penn State within the next year. We have calves on feed right now that another graduate student is working on. She actually has health data on these calves starting as itty bitty babies. So they'll be looking at both liver abscesses and lung scores after we kill those calves. So TBD. It's also interesting because in Pennsylvania, we manage our feedlot cattle a little bit differently than in other parts of the world because we have more available feed like corn silage. So our beef on dairy calves, even though I said they were on a mostly grain diet, fed really intensively, they still had about 17% corn silage inclusion in their diet. So they're getting a little bit more forage, and potentially that might be reducing some of the incidence of liver abscesses that we see in the Northeast in general. We see a lot fewer liver abscesses. So no good answer for you, but hopefully in a few weeks that other presenter will have better data for you.
One last, and I think we did get another question about morbidity and mortality with different crosses. Anything you can share on that? You did touch on some of that.
Yeah, so like I said, we didn't have enough Wagyu to start with, but then some of them died. Unfortunately, because we had so few of those calves that year, statistically, there were no differences. So again, not great data, but hopefully next year, because we have the student working on it and health things, they might have some better answers for you. But generally, we saw bigger differences in morbidity and mortality over a year versus over sire breed, and a lot of that had to do with management. So in 2021, we had just started this project working with baby calves, and kind of following that, we reworked different management protocols to improve calf health.
And a final question, has your research been published? And if so, where? And if not, when?
That's some great questions. So the dairy cow data is published in the Journal of Dairy Science. And then the probably more exciting to this audience, the growth and carcass data was just published in Translational Animal Science. I'll probably have another paper coming out in the Journal of Animal Science that I will be submitting very shortly, related to using a commercial genomic test on these calves, a little bit less applied, but something a little bit different as well. So the papers are coming out.
Excellent. Very good.
Thank you very much for having me.
Excellent presentation. Thank you very much for joining us, Bailey.
Yes.
With that,
thank you, Bailey. Yeah, so thank you, Bailey, for joining us. That was great. I loved it. I just want to also give a shout out that next week we will be moving on, and Dr. Olivia Genther Schroeder with Purina Animal Nutrition, as well as Dr. Jennifer Spencer with Texas A&M AgriLife Research and Extension Center will be giving their presentations. Dr. Schroeder will be giving it over the targeted nutrition, building a better beef cross starts on day one. And Dr. Spencer will be focusing on that neonatal management for successful dairy beef crossbred systems. So if you like this one and want to come back, please do. And if you have any questions, feel free to reach out to us as well.
I am posting the links to a couple of articles from Dr. Basiel, and hopefully you can access those articles from Translational Animal Science. One of them is an excellent review article on including crossbred beef on dairy in these modern production systems, and another is the actual research from her dissertation. So with that, thank you very much for attending our Ranchers Thursday webinar series, and we look forward to seeing you next week.